Hey guys, how's it going? Today I want to talk about section 2.7, cosecant and secant graphs. So it is important to note that this will be the last section of the chapter, which means quizzes and tests next week, okay? So I'll try to keep this video a little bit shorter than the last one, so I'll just kind of get right to it. With cosecant and secant graphs, it's important to note that, like, what is cosecant? Well, cosecant is really nothing more than the reciprocal of sine, which means if I can draw the sine graph, I can use that to draw what the cosecant graphs look like, okay? So we know our sine graph here. Like, let's say we just want to draw our sine graph. This is our standard sine graph, which means it has a period of 2 pi, amplitude of 1, right? So I can draw that sine graph, right? Has a period of 2 pi. We'll cut that in half pi, cut that in half pi over 2. This would be 3 pi over 2, amplitude of 1, right? So this, midline, peak, midline, peak, midline. Okay, this graph, I'm just going to draw a dotted sine graph. This is not actually our goal here. Our sine graph here is going to give us what our cosecant graph is going to look like, because now all we have to do is think about, take reciprocals of these numbers. So what is the reciprocal of 0? Well, the reciprocal of 0 is undefined, which means anywhere that this touches the x-axis, we are going to have an asymptote, okay? Because it has to be undefined. So we're going to have an asymptote at 2 pi, we're going to have an asymptote at pi, we're going to have another asymptote back here at 0, okay? Okay, what is the reciprocal of 1? Well, the reciprocal of 1 is 1, so it's actually going to hit that same point. What's the reciprocal of -1? -1, so it's going to hit that same point down there. Now, what's happening in here? Well, these numbers are getting smaller and smaller and smaller. They're getting closer and closer and closer, right, to 0. If you take a number that's closer and closer and closer to 0 and reciprocal it, like, what's the reciprocal of a half? It's 2. Reciprocal of a fourth is 4. What's going to happen is this is going to keep getting bigger and bigger and bigger and bigger and go to infinity. And the same thing's happening over here, so that means the same thing's going to happen over there. So we're just going to get this. It kind of looks like a parabola, but it's not, because it's bounded by these asymptotes, okay? So, but we get this U shape going up. And then the same thing is going to happen over here, except now we're doing it from the negative point of view. So we have like -1/2 would be -2, and things like that. So this is going to be a U shape going down, okay? Now, all cosecant and secant graphs look very similar. What they look like, if we just do a real quick graph of 1 divided by sine of x, that's the only way to type in a cosecant graph, and we do a quick zoom to a zoom trig window, which is number 7, okay, you'll see that this cosecant graph just looks like this U shape going up, U shape going down, U shape going up, U shape going down, okay? Over and over and over. Now, there's some important characteristics to look at with this. One, there's this gap here. There's no points in that gap. Well, what's going to control the size of that gap? If you go back to our graph over here, you know, here's our gap. Our gap, there's no points in this window here, okay? That's where our sine graph was. Well, what controls that is the amplitude. The bigger the amplitude gets, the bigger this gap here is going to get, okay? And then for our purpose, again, we're going to draw our periods, 1 period. So if sine has a period of 2 pi, or the way we calculate it, is 2 pi divided by b, it's going to be the same as cosecant and secant, okay? So here's how we are going to draw these graphs. Let's just jump straight to a complicated one, okay? If we can do this, we can do any of them. So whenever I see a graph like this, the very first thing I do is I'm going to rewrite this. I'm going to graph the same thing, except instead of cosecant, I'm going to graph the sine version. Okay? And I'm going to leave everything else exactly the same. Now, we can get our important characteristics. We know our amplitude is 3. We know our period is 2 pi divided by our b, which is 4, which would be pi over 2. We know our phase shift is going to be right, pi over 4. And we know our vertical shift is going to be up 2. Okay? Now, we can put all that, we can start drawing this sine graph. We should already know how to draw this sine graph. So, we put our x-axis in, make sure I give myself a little room to go up. Put my y-axis in. I know I'm going to the right, so I can put my y-axis way to the left. I'm going to go right, pi over 4. Okay, that's where I'm going to start. That's my left boundary. Remember, to get my right boundary, I have to add my period, right? 1/4 plus 1/2, well, that would be 3/4. Okay, and then I can just midpoint that out. So midpoint here, if I add those up, 1/4 plus 3/4 is 1. Half of 1 is 1/2. Okay, and midpoint here, this would be 2/4. 2/4 plus 3/4 would be 5/4. Half of that would be 5/8. Midpoint here, 1/4 and 2/4 would be 3/4. Half of 3/4 would be 3/8. Okay, I have to put my midline in, which is going to be a vertical shift of up 2. Make sure you're drawing these midlines. It's going to help you draw a much better accurate graph if you're drawing that midline in there. Okay. Now our amplitude is 3, which means from here we're going to go up 1, 2, 3, up here to 5. We're going to go down 1, 2, 3, down here to -1. So when we draw our sine curve, we would go midline, peak, midline, bottom peak down here at -1, midline. Now, this is what our sine curve looked like. Now, based on this, we know where everything should be. Remember, we haven't drawn a single bit of our actual cosecant graph yet. We're just going to use this graph to give us what we want. Anywhere that this sine graph hits our midline, we know we're going to have our asymptote. So I'm going to have an asymptote here at 3 pi over 4. I'm going to have an asymptote here at pi over 2. I'm going to have an asymptote here at pi over 4. Okay? And then wherever the peak is of this sine graph, that's going to be the trough. That's going to be the bottom of our U shape. So our U goes up from there. The bottom of the sine graph is going to be the top of our U shapes going down. Okay? So this is how we're going to draw all our sine graphs. You don't actually have to draw this dotted line for the sine graph. That's not part of the graph. The only part here is this green part, this U shape and this U shape. But you also need to draw your asymptotes in. Okay? It's also important to note you have to be able to identify that gap where there's no points. There is no actual points through here, right? There's no green points that come down into this gap. There's no green points that come up into that gap. There's no actual points in here. Remember, this blue stuff, these blue lines, that was the sine graph. That's not really part of the graph. We actually could just erase this. But I like to leave it just because it helps us show how we got where we got. Okay? Let's try another one. Okay? Before we do that, I do want to make sure that you guys are clear. The way we find our periods, this is now basically done for the chapter. If you're drawing a sine graph, a cosine graph, a cosecant, or a secant graph, the way you're going to find your period is 2 pi divided by b. The only two weird ones, the only ones that are 1 pi divided by b, are the tangent and the cotangent graphs. Those are the only weird ones, okay? And really, tangent is the only weird one that you start in the middle. Remember, like with this, we went to our phase shift, we went to our left boundary, we added our period, we went start and finish, and then we midlined it, worked to the middle from there. Tangent was the one that we started in the middle and we worked out from there. Okay, so tangent is really the one that's weird. So, all right, so let's try another one. Let's try a secant graph. Okay, these are actually my favorite ones to draw. I'll show you why. All right, so first thing I'm going to do is I'm going to draw the same exact thing, but I'm going to draw the cosine version. Okay, because secant, cosecant, or cosine and secant, those are reciprocals of each other. All right, so amplitude's 4. Period would be 2 pi over 3. Phase shift would be left 1 pi over 3. Vertical shift down 3. So I got to move left and I got to move down. So I got to give myself some space to move down. So I'm going to put my x-axis a little higher. Okay. I'm going to put my y-axis right in the middle. Okay. And the reason I'm going to do that is I know I'm going to move left a third. So I'm going to be back here at negative pi over 3. And then when I add my period, right, I'm at negative 1/3. If I add my period of 2/3, I'm going to get positive 1/3. Right, negative 1/3 plus 2/3, that'd be positive 1/3. Well, midpoint's really easy. That's 0. Midpoint here would be a 1/6. So that means this midpoint over here is negative a 1/6. So we've got our 5 points. I got to go down 6. 1, 2, 3, 4, 5, 6. Draw that midline in there. Okay, amplitude's 4, so I got to go up 4. 1, 2, 3, 4. Up here to negative 2. 1, 2, 3, 4. Down here to negative 10. Okay. And now I'm going to draw my cosine curve. My cosine would start at my peak. I'm going to do green this time. Start at my peak, I'd be up here. And I'd go down to my midline, down to my bottom peak, which happens to be on the y-axis, back up to my midline, up to my top peak. Okay? And again, yes, you can draw that curve. Okay? Now, again, this cosine curve is not part of our graph, but it is going to tell us how to draw our cosine or our secant graph. Wherever it hits the x-axis or our midline here, I know I have an asymptote, so I have an asymptote here at pi over 6. I have another one here at positive pi over 6. Okay. And then I can draw my curve. The curve, this top peak of the cosine, that's going to be the bottom of our curve. So I'm going to go up there. Now, I'm only drawing half of my upward U here. The other half is going to come over here, and that's going to be the back half. Okay. So our top half kind of gets our top U kind of gets cut in half. We're still drawing the full U shape, but because of the way we draw our cosine graphs, it kind of ends up looking a little different. And then down here, we draw our bottom U, okay? And then that's what our graph looks like. Now, for me, what I personally like to do, this is not mandatory at all. I like to, draw a little extra, little oval shape around there. Put a smiley face in there. I kind of have my little Fu Manchu guy there. He's got a sweet mustache, got some cool eyebrows. Some people think it looks like a giraffe, but you don't have to put that part in there. But yeah, there's our vertically, or our U shape going up. Here's our U shape going down. This is still one full cycle, okay? It just kind of looks a little different. Let's try two more just to make sure we got it, okay? Now, remember, anytime you see the B on the inside of the parentheses, the very first thing you have to do here is pull that 3 out of there. Which means if I divide this by 3, I have to divide this by 3, which makes that 2 pi over 9. Okay? So again, first step, I'm going to draw the same thing, but just the sine version. Sine is a reciprocal of cosecant. Okay? So that means my amplitude is 1. My period is going to be 2 pi over 3. My phase shift is going to be left 2 pi over 9. Vertical shift down 2. Okay. Put my axes in here. I need some room to move down. Make sure I have room to move down. I got to move left 2 pi over 9. Now I'm going to put my y, this is a helpful tip too. Sometimes it's easier to put your y-axis in later. I'm just going to go left and go negative 2 pi over 9. Okay? Now, I got to add my period. You can do a common denominator. It's not that hard, but if you guys want to, feel free to use this. I'm at negative 2/9. And I got to add my period of 2/3. Okay? That's all you're doing. That's just 4/9. When I add these together, it's just going to be positive 2/9. Okay? Or 4/9. So, because that's 6/9, right? Yeah, so that's 6/9 minus 2/9 would be 4/9. Half of 4/9 should be 2/9. Okay? Now, the reason I waited to put my y-axis in there is now it's easier to put it in after the fact. I put that here. I got my endpoint. I know exactly where my y-axis should go. It goes right in the middle because that's the midpoint here. Midpoint would be 1/9. Midpoint would be negative 1/9, right? I got to go down 2. I probably should have written all those above the axis so they're not in the way of my midline here. I'll just kind of jump over top of them. Okay. My amplitude's 1, so I'm only going up and down 1 here. Okay, and I'm going to draw my sine curve. Now I'm not actually going to draw the wave. I'm just going to put the points in. I'm at midline, peak, put that right there. Midline, bottom peak, midline. You don't actually have to draw that wave if you don't want to. But I do know where I need asymptotes. Anywhere I'm on the midline, I have an asymptote. So I have one here at negative 2/9. I have one here at 0. Don't need to really draw that one because it's on the axis. And then I am back here at positive 2/9. And now I can draw my actual curve. From here, it's got to go away from the midline, so it goes up from there. And then away from the midline, it's got to go down from there. Okay? Again, there has to be that gap. So there's no points in here there's no points actually between -1 and -3. Okay? Let's try one more secant graph just again to make sure we got it. Again, step 1, got to pull that 2 out of there. So this, I'm going to graph secant of 2x plus, if I divide this by 2, I get pi over 4. So I'm going to graph the same version, but just the reciprocal version, which would be cosine in this case. Okay. Got to find my important characteristics, which means my amplitude. Now, there is no amplitude technically to the cosecant and secant graphs because there's no max and no min. But what the amplitude basically, again, gives us is it gives us that gap. Okay? So the gap is going to be 1, up and down 1. Our period is 2 pi divided by the b, which in this case is 2, so that's 1 pi. Phase shift would be left, pi over 4. Vertical shift, down 1. So here's another way I like to do this. I'm going to go left, pi over 4. I'm going to add my period. -1/4 plus 1 would be positive 3/4. Let me put it up here. Okay. Notice I haven't put my y-axis in yet. I'm going to add those together. -1/4 plus 3/4 is 2/4. Half of 2/4 would be 1/4. Well, I now know exactly where my y-axis is. That's the midpoint here. So I put my y-axis in almost at the end. A midpoint here, and that would be a half. And then I can put my midline in, which is going to be down 1. So this is where my midline is, always at my vertical shift. I got to go up and down 1 from there. So up 1 to 0, down 1 to -2. This is a cosine graph, which means I'm going to start at my peak here. I'd be midline here. Then the next point would be the bottom, back to the midline, back to the top. So I have asymptotes here at pi over 2 and 0. From here, it's got to go up. From here, it's got to go down. And then from here, up. And again, it never hurts. Throw, a little extra detail in there. Never really hurts anything. Put a little smiley face in there. All right. Hey, try a few of these and let me know if you guys have any questions. There will be a quiz next week. I'm thinking maybe Tuesday. And then we'll have the test on Friday. All right. I will talk to you guys later.